The base topic is the relationship between the air gap power, losses, gross, and the net torque. So the when there's a motor, you provide a supply to the motor stator winding. So stator winding produces a magnetizing flux. Those flux are revolving. They are revolving. Their speed is similar to the synchronous speed. They are rotating at the synchronous speed. So those flux are passing through the rotor bar, and then so body induced in the rotor bar. At the same time, the current is also induced in the rotor bar. So the those stator magnetizing flux and the magnetic flux produced by the rotor bar current, they make the interaction and it's rotating the motor. So the those flux are passing through the stator winding to rotor bar. So those flux are in air gap. So this is we call the air gap flux. So this air gap flux also carry the power. So I will now calculate the power carried by the air gap, and those are power develop the mechanical torque. So also I will calculate the mechanical torque. So formula for the air gap power and the mechanical torque power produced by the three-phase induction motor. So this is for the diagram of the three-phase induction motor here. Induction motor. So this is the supply coming in. So this is why we provide active power to stator. So there will be PS. PS is active power to stator. So there will be power loss here. I square R loss. So this also there's another loss with the iron loss. So then this power output produced by the stator is active power supply to rotor. P0 is the active power supply to rotor. So this is rotor winding here, so this is rotor bar. So they produce a rotor bar here. So this because a power loss also happens. This is the I square R loss. So this becomes a power with a mechanical power.
The loss is when you run to the show.
Yes, rotor attached to roller. Yes. So this is for the mechanical power.
So any kind of loss.
Yes, eddy current and the hysteresis loss happen in the rotor. Iron loss, the eddy current and the hysteresis. So firstly, we get the eddy power to stator. So stator copper loss, the I square R loss. I square R loss is stator copper loss. And also the iron loss. Then the resultant power is active power supply to rotor. So the power supply to rotor, so in the rotor winding process winding to I square R loss also happen. So this is the I square R loss. So then finally we use the mechanical power. So this mechanical power is also loss, windage, and friction loss. And this friction loss are you subtract and finally we use the shunt power. So then we shunt power. So then we use the PSP. So this is the shunt power, PSS. So this is for the power flows configuration for the motor. And then we can also calculate the rotor I square R loss. Rotor I square R loss. So this way we can calculate this with the slip multiply active power transmitted to rotor. Active power transmitted to rotor. So this we can calculate the slip multiply P0. And also the mechanical power developed by rotor also we can calculate. This is the formula for the mechanical power developed by motor. So mechanical power developed by rotor, we can also calculate this is the Pm. So that formula is active power transmitted to rotor. Minus rotor I square R log. So this is formula. So that way the formula is a P0 minus S into P0. So Pm is equal to 1 minus S into P0. So the mechanical power developed by the rotor can be calculated. Pm is equal to 1 minus S into P0. And also the Pm is for the mechanical power developed by rotor is that we can also calculate. So Pm equal to rotor speed multiply mechanical torque. Divided by the 9.55. So we can calculate like this. And also that we also calculate the mechanical power developed to load. Also can be calculated mechanical power. Deliver to load. So mechanical power delivered to load, we also calculate this with the Pn minus friction and within load. So Pn minus friction and within load we can calculate by this way. And also we also calculate the mechanical torque. So mechanical torque we can also calculate that with the Pn multiplied by 9.55 divided by rotor speed. So just we calculate our Pn. So Pn is equal to Pn multiply 9.55. So and 1 minus slip multiply synchronous speed. So this is for the we can calculate for the motor torque. So Ns you also calculate. Ns equal to the F divided by C by 2. So this is for the Ns. So this is the equation for the power flow in the motor winding from the stator to the final shaft power. We calculate and store and the power are related by this formula. Another problem. The next topic is the relationship between the air gap power